In this video, I'm going to teach you the basics of image classification using Google Earth Engine. In my script, I've created a geometry over the Alaskan Peninsula. I've also imported the Landsat 8 Level 2 Collection 2 Tier 1 Surface Reflectance image collection. And I've created an image using that Landsat 8 image collection where I filtered out clouds. I also filtered the image collection to only include summer months, so months between June and September. I filtered the image collection by my geometry, got the median, and clipped it to my geometry, and visualized it as a true color image. For the purpose of this video, in this classification, I am going to classify this image into 3 classes: water, ice, and land. So it's important to figure out what you'll be classifying your image into before you start the process of collecting training data. We will also number each of these classes within our geometry imports in a second. So really quick, I'm just gonna write up here that I'm gonna make water equal 1, ice equal 2, and land equal 3. And this will make sense in a second. Okay, so the next step in creating a classification is to collect your training data. And in Google Earth Engine, if you don't have training data that you import, you will typically be manually creating that training data by looking at your map. The way that we're going to do this is we are going to create 3 new layers representing our 3 classes that we will classify. We can click in here and rename them as our land classes. So the first one was water. And then this is really important. I'm going to change this import into a feature collection. I'm going to add a property, which I'm going to call class, and then I'm going to set the value to that number that I had specified before for water. So I said water was going to equal 1, so I'm going to put value is 1. Then I'm going to click OK, and then I'm going to do that to our other 2 geometries as well. So I have ice. I'm going to put it as a feature collection. I'm going to add a property called class, and the value is going to be equal to 2. And I'll do the same for land. Make it a feature collection, add a property, class equals 3. The next thing that we're going to do is we are going to manually collect our training data. So in order to do that, we're going to do this separately for each of our 3 geometry imports. I'm going to click on the water class, and I'm going to collect point data. And now I can click in the map everywhere that there is water. And you can decide how many training points you want to collect. I'm going to collect about 30. I'm going to place these in areas that span my entire ROI, so I get a good mix of water points. And I'm going to do the same thing for ice and land. So I'll click on the ice, and then I will put these points in areas on my image where there is ice. It's important to use the image that you will be classifying, in this case, this L8 image, in order to create your training data. Because if I, for example, used the satellite imagery, it could be that there is ice in the satellite imagery in some places where there isn't in my Landsat 8 image. Because the Landsat 8 image is the one that will be classified, we need our training data to correlate to that. I also need to be a little bit careful because there are some clouds, so I want to make sure to only put the training data where there is ice. Great, and now I'll do the same thing for land. So I'll collect about 30 points in areas where there is land. And in this landscape, you have to be a little bit careful as well, because some of the areas that look like they're land might also be a lake that just has a lot of sediment. Your classified map will only be as accurate as your training data. Okay, great. So I think I have enough training data now that also stretches roughly my entire ROI. So the next thing I'm going to do is I'm going to combine my training data into a single feature collection. I will do that by EE feature collection. And then I'll add my 3 feature collections here in a list: water, ice, land. And then I'm going to make sure that this is just one single feature collection and not a list of feature collection by using this function called flatten. So next, we are going to sample our feature collection using our L8 image. And it's important at this step to also determine what your prediction bands are going to be. So in L8, we have a lot of bands that we can choose from, but not all of these bands represent surface reflectance data. So some of them, for example, represent pixel quality. I, in this case, am only going to use bands 1 through 7 as my prediction bands in my classification. So I'm just going to specify that down here. Variable prediction bands, and then I will set that equal to a list that includes bands 1 through 7. And next I will sample my points. So I'll create a variable called sampled points. I'll select my L8 image, and then I'll select those prediction bands. So that will return my L8 image, including only the prediction bands. And then I can sample those regions using the sample regions function. The collection I'm going to use is this training data feature collection. The properties that we used are called class, and then the scale of this image is 30. We can also print this sampled points feature collection to understand what's going on in here. Basically, what this sample regions function does is that it takes each one of these training points and it will return the pixel values of the L8 image at that point, and only for the prediction bands that we specified. So we can go in here and see that specifically. So we have this first feature, which was of class 1, which was class water. And now we also have all of the reflectance values for our 7 bands at that point. Next, we can create our classifier. And in this case, I'm going to do a random forest classifier, though there are a lot of classifiers within Google Earth Engine that you can choose from. I'm going to create a variable called classifier, and then I'm going to put this classifier that I decided to use, random forest. Within the parentheses, I'm going to specify how many trees I want my random forest to have. I'm going to say 100. Then I'm going to train using this random forest classifier. The features that I want are my sampled points. The class property, again, is called class. The input properties are the prediction bands that I specified earlier. And that's it. So that is our classifier. We have not yet classified the image. This just tells us how we will classify the image. And now finally, we can apply our classifier. After we apply the classifier, this will be our classified image. So I'm gonna name this variable classified image. I'm gonna take that original L8 image. I'm gonna again select my prediction bands, and then I'm gonna use the function classify and tell it to please classify this L8 image using that classifier that we just defined called classifier. So that's it. Now we have a classified image called classified image here, and we can add it to our map. Within my visualization parameters, some helpful things to include are the palette. In this case, I'm going to have 3 different classes representing water, ice, and land. And so I'm going to choose colors that make sense for each of those land classes. So for water, I'm going to put blue. For ice, I'm going to put white. And then for land, I'll put green. The min will be 1 because remember the lowest class that we had for water was 1, and then the max will be 3, and then we can label the layer classification. Let's run that and see what happens. I'm going to turn off my geometry import so I don't see them. And here is our classified image. We might want to zoom in to see specific areas and how accurate they seem to us. And at this point in your classification process, you might determine that the classification is not accurate enough and you want to improve your classification in some way by, for example, adding more training points. Maybe you want to select different prediction data. Maybe you want to calculate NDWI and use that as one of your prediction bands. So there's different options here to make your classification more accurate. A good next step would be to actually run an accuracy assessment for your classification, and I will show you how to do that in a separate video.